Good morning, everyone. And today this is the Computational Social Science monthly webinar hosted by the Computational Social Science Lab at the Chinese University of Hong Kong. So today we are very happy to invite the Professor Liu Yan to be here. Professor Liu currently is a professor of Geographical Information Science from the Department of Geography and Resource Management at the CHK. She used to teach in Singapore and also Australia and just joined us recently. So Professor Liu is an internationally recognized scholar in urban science and spatial data science, specializing in GIS, urban analytics and modeling, and also spatial social studies. Her research outcome has broad impact across coastal city development, urban and regional planning, social equality, and healthcare policies. She has been recognized as among the world's top 2% scientists by Stanford University, and she also received a lot of awards. And yes, so without further ado, let's welcome Professor Liu. Thank you very much.
Thank you, Professor Liang, and good morning, everyone. It's my great pleasure to be here and then to share a part of our research. And today I'm going to talk about spatial data mining to understand the neighbor problems and the neighborhood change. This research was conducted actually when I was working at the University of Queensland in Australia under an Australia Research Council grant. So I want to acknowledge that at the beginning, and also the work with my colleagues, Professor Linda Cheshire, and then other colleagues at UQ. Here is an outline about what I wanted to do. So I'm going to give a brief introduction about neighborliness and the neighborhood and neighborhood problems. And I'm going to talk about the data aspect, how we can use spatial and then spatial data mining approach to understand neighbor problems. And then I'm going to present in a bit of detail the first two case studies on how we use the data that we extracted through this spatial data mining to address some of the social urban problems. And then that includes neighborhood complaints and the type of neighborhood complaints, and then also how the changing urban process, such as gentrification and densification, impact on neighbor relations. And then if time permits, I can also expand to talk about other studies that we have done. For instance, like neighborhood characteristics and then how that inform and formulate neighbor relations. And then even some of the other aspects that we explored using the same set of data that we extracted. For instance, the seasonal change of neighbor problems, given the weather conditions, particularly in terms of noise complaints. And then I'm going to give some conclusions and discussions from there. So to start with, sociology aspect, everybody needs good neighbors. We have a lot of studies looking at the good aspect of neighbors. We know how important it is to have a good neighbor and then to have a quality of life and then harmony in our societies. So everybody wants to have a good neighbor. However, in reality, there are still a lot of different type of problems that we encounter in our daily life. And then some of these pictures that are illustrated the varied issues that we probably have encountered, such as noise, such as debris, such as privacy issues, and then so on. So anyway, we all have this type of experience, and then we know that unevenness issues does like appear in our everyday. And then some of you may have even played some games like this neighbors from hell. And then there are Chinese versions of this neighbors from hell, number one and number two, and then you can see, and then you may have experienced how terrible it can be if you have such a neighbor there. And then there are also a lot of research on this aspect, looking at issues between neighbors. Some more serious even go to court and so on. However, looking at this the negative side of neighbor relations is more challenging than looking at the good neighborhood and then the neighbor relations. One part is because of the difficulty in getting good data to have a holistic understanding about what is happening, and also uh, objectively assessing the issues there. So this is what we are facing when initially we look at this project to try to understand unlevelness aspect of the issue. So, and then we put quite some effort to look at one type of data that actually experience in all cities, which is the administrative type of data. For instance, in the US, the 311 city hotline data that has been used by scholars, but by scholars more looking at neighborhood issues, like, for instance, the ecology of neighborhood disorder, neighborhood companies. So I wanted to draw a line, the difference between neighborhood problems or disorders and neighbor relations. Neighborhood issues is more about things that are happening in our neighborhood environment, but it doesn't tailor about people-to-people relations, where neighbor problems is more about how you deal with any problems with your neighbor, which is a people-to-people, family-to-family issues, rather than things that are happening in the environment that you live. So 311 data has been used quite extensively in the US to look at this neighborhood issues, which are quite interesting and empowering to understand those issues there. But our issue is more using how we can actually use those similar type of city hotline data to extract the type of issues that may relate to people issue. And that's say where we can see whether our spatial data mining approach can be applied to dig into this mayor hotline data to address those neighbor relations. So we contacted the Brisbane City Council, which is where our University of Queensland are sitting, and then we approached them, the Brisbane City Council. They do have a department called the Brisbane City Council's Compliance and the Regulatory Services. So we call it CARS branch, and then they collected the data on a routine basis. And so we approached them for this project. We actually got 11 years of data. I will come back and then to see how we get the data and how difficult that data, like to get the data from. But anyway, we got the data, and then the data can be phone calls. People can call the council if they have a problem. And then I wanted to say, particularly in the Western context, if you find that midnight your neighbor is having a party, normally you don't go and knock the door and then have a direct conflict with them, confronting them to say, hey, it's too late to have such noise there. but rather you will go into a third party like the Brisbane City Council or other third party to report the issue, so you don't have direct conflict with your neighbor. You will have to live with them for a long time. And then so those data doesn't have to be phone call, can also be online. So you can report online. And then if the issue is serious, and then if the issue persists, then the council will actually interact and then deal with those issues there. And then so over time, then the council have a large record of all the issues that have been reported to them, and then they have once they deal with the issues, normally they wouldn't go further to investigate collectively whether there is any emerging issues, patterns, as we as researchers would be interested. So here are those some of the examples and the channels that they can connect those data. A summary, I sort of show some of the snapshot, but given the confidentiality issues there, I'm not going to show the actual record. But over that 10 plus years, the council have collected actually 500,000, more than 500,000 record of those issues. When people report those issues, they will need to record the date, the nature of the complaints, for instance, whether it's noise, whether it's some animals that are found on the street, whether there are abandoned vehicles on the street, or unmaintained gardens and so on. So they will also need to report who you are, where do you live, the address of the reporters, and then also they will need to report the site of the issues that they identify. So for instance, the address of the other parties. And that is where the spatial information becomes important for us to see whether we can extract to identify the two parties involved, the reporters and then the complaint side, whether they are neighbor or not. And then, so it actually took us a long time. I think I missed that part. It took us a long while for us to negotiate with the city council and then to go through a series of confidentiality procedures to eventually that they gave us the data. And then together, I think we go through almost 2 years. One part is that we have to commit to all the confidentiality issues because it does involve individuals and then the address that are available there. And then also the university is, we have a good reputation university that are backup, and then we are committed to keep the data sets confidential. There is no email transactions about those data once we got it. So we analyze data within our research team, and then we are committed to keep all the address. When I give report, and then some people and then say that, can I know which suburb is good? And then when I buy the properties, I need to find the good neighbors there. And then we can say that we talk about the issue, we talk about the urban issues, but I can't release any individual data about which area is a good area to buy a property. So once we got the data, we have to go through a series of process of how we can filter out those data that cannot be used. For instance, if there is no address, particularly for our purpose, we cannot use data that have no address or the address are the same address, which could be a report about issues of the same site. And then we remove the record of issues that are not residential. For instance, some of the commercial premises that can also report the issues like nightingale, noise pollutions, and so on. But that is not in the residential premises, and then so are excluded there. And then we bring in a set of other data, for instance, the GNAF data. For geographers that probably know what GNAF data is geocoded national address file, which have all the address that can be used for us to geocode the data with the address that we get from the data to position them in the geographical locations, the actual address that are on the street. I'll show some example here. So this is how after we geocode all the record using the reporter's address or the complaint side address, then we can get a lot of points to illustrate where the locations of the core site and then also where the locations of the other parties that are involved, the complainant and the complainants. And then so that is when I put it on the map, how it looks like. And then if I get the two parties involved, so to connect the one who reported the issue with the one or the site that the issue was reported. And then if I connect the two together just to use air distance and then to show, and then it doesn't look like they are neighbor. So this is the whole Brisbane map. And then the area could be as far as say like here, the biggest is 67.7 kilometers apart. How that can happen? Like it does happens when, for instance, if I'm a good citizen and then I drive past somewhere and then I saw there are problems, there are abandoned cars, then I can call the council and then I can report the issue. And then if I can see there is a barking dog on the street and then causing troubles to people, I can also call and then I can report the issues. So the issue has been spreading everywhere. But I wonder whether there are ways that we can identify whether it's the people-to-people neighbor-related problem. And then using GIS, we can identify such issues. For instance, I can set up a proxy. Neighbors normally would live quite close. So in Australia's context, we said, say, like within 100 meters, they could be neighbor. Most of the properties are detached house, so they have a front yard and a backyard. So 100 meters could be quite safe to say that out of 100 meters, they may not be neighbor. And then so we can exclude all those pair that are far away, at least 1 kilometer away, so we can exclude all those set of data. And then we can also set up a set of other criteria. For instance, neighbors would share a property boundary. So all the properties would be connected, share a common boundary, or they can be within 100 meters that are away in front or on the back. However, particularly also we used another set of data called the digital cadastral database, which are freely available from the government. So it actually shows all the properties, the property boundaries. So that is the cadastral boundary. So if I put the point that I extracted from the complaints data set, and then you can actually see those complaints are sitting within a digital cadastral boundary area. And then if they are labeled, then it will share a boundary, or they could be within a certain distance. And then there are some properties that could be quite big acreage, like some of the particularly prevalent areas that have large properties that are owned by individuals. So if we only use, say, 100 meters, that could exclude those larger properties. So instead of using an arbitrary 100 meters or so, then we actually use what we call the topological data relationship in GIS to see whether the property actually share those boundaries regardless of the distance. I show you example as to say, so for instance, if this is how, if it's smaller properties that could be somewhere across the line like this one. I don't know whether you can see my pointer here, but if it's a bigger property, then it could be 240 meters apart from one another, but then they still share a boundary. So using the cadastral boundary, it can actually help us to identify more accurately whether they are indeed neighbor or not neighbor. And then even for some of them, if they are not a very neighbor, but they cross the street, and then they are still considered neighbor. So that gives us a full set of data that can help us to understand neighbor related issues here, regardless of whether they are packed small area properties or if they are large properties. For instance, this is an example where we have small properties that they can see who is complaining who, and then I have the arrow to say the source, which is the black side, and then this is the source, someone from this property complained about somewhere else from the property that I indicated in the red triangle area. And then so I used the pointer to see the one complaining the other one. And then you can see the complex relationship between the one who reported the issue and then the one that has been complained. And then so here is the small properties. And then here are some of the larger areas. And then those areas you can see there is a much bigger scale. And then those are acreage properties. And then even though these are smaller, we didn't want to exclude any of the possibility about those neighbor-related issues. So we want to say for those more affluent areas, is there also property neighbor problems, or is there different type of problems that are existing there rather than or they are happily living there in the more affluent areas compared to the more compact areas there. So this actually gives us a full coverage of what is happening in all areas in the city. So after all this process, then we get a much smaller set of data from the original 450,000 data that are all with address to a set of data that a total of about like 110,000 data, so about 1/4, quarter of the data are indeed neighbor related. So, and then we are confident that they are all neighbor related complaints. And then with the time, then we have can do a cross-tabulation to show how those reported issues are appearing. And then the council does initially have some like classification of the type of issues, the nature of the problems. So you can see that I listed, I think it's 19 here, I didn't count. But the original nature, the council have much massive, and then I think more than 50 different type of complaints. Then we group them into 19. Still, some of the issues could be related or in similar categories. So what we have done, so this is how it looks like all together. So it's not the long distance that we saw before, but still we wouldn't be able to see if we don't zoom in here. So with this data set, then we come to formulate our research questions. We have a series of research questions. So I will show some of this here. And then actually we find after we get this data, we have a lot of things that we can do to explore. And that's where I have a few case studies to illustrate later on. So for instance, we want to ask what type of neighbor problems exist in our urban space? How do they vary across different suburbs and then in different contexts? So that is more about geography issues. And then we also could ask, how might urban policies and change processes, such as urban consolidation, gentrification, concentration, concentrated disadvantage, and so on, and the urban renewal process, and all of those processes can influence the prevalence of neighbor problems. That is more about a social type of issues there. How does the built environment and the social economic factors impact on neighbor relations? And then the physical disorder of neighborhood, which are the second part of this question is more about similar to what this 311 type of data has been used for. And then we can also ask a series of other questions. For instance, like how neighborhood characters affect the neighbor relations. And then whether there are, like, for instance, we have temporal data, we have data by year and also by seasons, by months, even by days. Whether certain type of issues, for instance, noise, are related to weather. Like hot seasons, people are more likely to complain, and then after the COVID, actually the council wanted us to do some more work. For instance, like during the lockdown period, when people are all at home, whether neighbor problems are becoming less or becoming more. We haven't got time to do that. We don't have funding to do that. But all these issues can be raised by using this set of data. So what I'm going to do is that I'm going to present a few case studies that we have actually published over time, and then to see how we have been using those data to explore a set of social urban related issues there. So the first one that I wanted to talk about is a paper that we published in the cities, a social spatial analysis of neighbor complaints using large-scale administrative data. The paper, the first part is about how we can use spatial data mining to extract the data, which I've already discussed. And then I'm going to focus on the research questions that we raised here. The first is how we can use those spatial technology, which I have already discussed. So I'm going to focus on the second part. What kind of issues include complaints from neighbors, and then to what extent a particular formation of neighbor complaints types experience together and why? So, and then also we say how are neighbor complaints spatially distributed across the city and over time, and how might we make sense of these patterns? This is more about, again, a geography type of questions. When we saw the data, when we see that problems appear in the geographic space, we want to see whether there is any patterns that we can identify. And then how can we make sense? How can we explain the emergence of these patterns? And then with that, then we come to some other questions later on. So to explore the data, we start by looking an exploratory factor analysis to identify the factor construct, even though there are typology that the council have done. Initially, it was coded and we counted. I see that actually we had 107 categories, and then we manually categorize these categories to 29, but then using manual calculation, and then it seems arbitrary to group that into actual factor construct. So we used the factor analysis. And then we used the confirmative factor analysis to verify whether the factor structure is useful. This method has been used by other scholars, like people when they used the 311 data in the US, also used a similar type of contact method there as well. So we very much used a similar approach there. And then we used spatial analysis that we typically use in GIS, the kernel density approach, to identify whether there are hotspots and the cold spots, whether there are patterns that we can identify. So here is what we get from the 29 type of factors. We used the factor analysis to identify 4 factors, and then the 4 type of factors are all confirmed by a confirmative factor. And then we have the factor loading that are making sense. So together we have 182 suburbs. So what we did is that for all the point data that we identify, so there is all over the years that are all merged together, and then we have grouped them by suburbs. So in Brisbane there are 182 suburbs, and then we use the factor analysis to identify the factor loading, and then to see for each of the original 29 factors how likely they belong to those latent factor, and then by how they grouping. And then so with those grouping, then we say, for instance, the dogs, other animals, animal attacks, animal noise. And then I come back to this backyard burning, and then the animal lost and found, the permit advice. Those all seems to be animal related. So we gave them a name. Factor 1 is animal related issues there. So this is our one type of factor that we identify. So one type of issues that we identify to be put that way. And then we still don't know why backyard burning and the smoke is grouped in that category, but it does have a factor loading of 0.59, which is much higher than if we try to put it in any other categories. So we leave it there. And the reported issues are relatively low, 1,074 reported issues they count. So we leave it there in this factor anyway. Then the second type of factor is building and construction related. And then the reason we put it there, because it's based on the nature, so soil and water pollutions and the general development components and so on. Those are all seems to be building construction related. So we gave that name. And then we have property maintenance related issues like parking and waste management, road pass hazard, and maintenance issues, pollutions maintained, and so on. So that is more related to property management. And then we have the fourth factor, health and visual amenity related. Some unsightly vegetations, people didn't maintain their gardens, and then those type of issues, insects, vermite, and then fire safeties, and so on. So those are the 4 factors that we identified by doing the factor analysis. And then with that, then we use GIS to do the pattern analysis. So if I just put all together and then with the 4 factors, so I separate all the data in by factor, and then I can map them out. However, by looking at mapping it out without even looking at where people live, it doesn't seem to be easy to identify whether there is any patterns. Then we use the GIS, and then we identify we actually controlled by number of household. So for some areas, for instance, those in the western side, there is less complaints because there is less people living there. And then so for some areas, there is a lot of complaints, but also there is also a lot of people living there. So we actually need to control the population density. So we use the household because it's house-to-house complaints. So we rather using population as a control, we use the household number as a control. And then we also have an issue about whether social scientists, my colleagues actually typically would also question there. So maybe there are some people who are more likely to complain. Then there are some other people who didn't have time, didn't care about that. And then, so how do you consider that? So that is actually a different issue. And then we did consider that. And then we wanted to actually do another research on this issue about the complainingness. How likely people to complain and whether there are some of the people that are more likely to complain. And however, for this study, we didn't do that. We used one type of issues that we identified that are more common, that people would be more care about it, as a way to see whether there are particular issues, there are particular areas that are more being complained. And then by using that residents' propensity to use council's car service as a control to see to control the even distribution or likelihood of people using the service. And then with that, then we identify the spatial patterns about complaints. So for each type, you can see that the distribution is different. Those that are in red shows that are higher concentration of complaints, where those in a lighter color getting to the green are very low concentration. So you can see animal-related are more spread towards the south, towards the north, south or east, where particularly for the factor 4, health and amenity-related issues are concentrated in the central area towards the south of Brisbane. For most people who are not in Brisbane, probably doesn't make much sense. The city center is somewhere here. This area is actually Brisbane, where our university is sit. Actually, it's a very low number of complaints in this area. It's an affluent areas close to the university. So we used another approach called hotspot analysis to identify whether there are concentration of complaints that are in certain areas that are also surrounded by high complaints in the nearby areas. That's where we call this hotspot. And then cold spot are illustrated as blue color, hotspot are red color. Those are areas that are more of a concern. That means there is one suburb that have a high concentration of complaints of that type, and they are also surrounded by nearby suburbs that are also have a high concentration of similar type of problems, and that we consider would need interventions, attentions in those areas. And then when we are overlaying or putting in context of the social demographic factors here, for instance, health and amenity related issues are on the southwestern side of the city. And this is actually also areas of very relatively low socio-economic status, like the lowest socio-economic status areas are all actually located in those areas. And then not surprisingly, the reported issues about health and amenity problems are concentrated in those areas. And then housing maintenance related issues also in the south, but also in the central and the central north. That is where new development and then regeneration of the city areas are also happening. So we have discussed all of those in the paper as well. And then animal-related issues also concentrated in the southern part where it has no socio-economic status here. Building constructions on towards the south and the western side, new development new buildings are constructing in those areas. So it does make sense that where those concentration of neighbor problems and the complaints are appearing in different patterns and then different part of the cities. So, and then we also have done some mapping over time to see how it changed over time. So I've just quickly go through this and then to show some of the patterns that we see, and then by year and then by days. So with this paper, the discussion part we have explained briefly in this talk. There are also more discussions in our paper. What we can say from this study is that we illustrate how we can use, we call it naturally occurring census data. So it's much more comprehensive than a survey type of data that we would have to do if we don't have this data, if we want to look at those unable issues. But it's very limited, wouldn't be able to give us a holistic understanding about what is happening in our whole cities. So the administrative type of data does give us a naturally recurring census to understand this type of issues. We did explain the coexistence of some factors like 2 and 3, and then how people use their space in relation to the development and how that trigger and then involve the complaints. And then we did talk about the 4 type and then how it relates to the social, economic, immigration, housing market, and then possibly gentrification, and then urban redevelopment issues. And that's where we come to our second study, looking at gentrification and then urban densification process, how those triggers. So we particularly looking at these 2 aspects, how it can impact on our cities. So this paper has also been published in Urban Studies. And so this is the whole 3 CEI that are in this project. How gentrification and densification impact on the neighbor relations. So get straightforward, we use the same set of data that we extract from the spatial data mining approach, and then we look at particularly the 2 processes of urban development, which is one, gentrification, the class transformation of urban neighborhood that has been studied extensively from the 1970s, starting from the UK, but globally, gentrification has been observed and then has been a major issue that social scientists has been studying on. And densification has also been happening in Brisbane. Some people may know that Brisbane is in most cities in Australia are considered low density with detached house. However, in the past 20 or so years, densification process has been emerging and then has been a core policy effort for urban development in Australian cities globally, but in particular, that is one of the major process that has been happening. But there is a lot of challenges there. We can talk about that in a separate time. However, our focus is to look at how these 2 processes impact on neighbor relations, given that we have a good set of data to look at neighbor relations, neighbor problems there. So what we did, we identified, so these are the potential source of complaints that can emerge. For instance, gentrification. Gentrification is more about class change. Because of class change, the absence and the tense relationship between middle class gentrifiers and the working class incumbents has been reported in the literature before, and then that can understandably happening in those gentrifying areas. So the different classes can come with conflicts. And then also because of the mix of different ethnic groups and then the social origins, those can also become a trigger for complaints. High density living obviously would have less space, and then noise could be a clear, obvious issues that can emerge. Theoretically, those could be the triggers for complaints. We do want to see from data what we can find. So from our data sets, we identified focusing on a number of type of complaints. For instance, the 9 type of complaints that are our first focus, noise, and then the other building compliance, vegetation, parking, and so on. And then so we used those 9 types of complaints for this study. And then we standardized all those steps. So here are the procedures. And then we didn't use all 11 years. We used 3 years that are closely related or to the census data, because we want to measure gentrification and densification. So we have to use census data, and then census data is collected every 5 years. So we used the middle year, and then we used the 3 years average of the complaints to go and then for the analysis together with the census data. And then for gentrification and densification, we actually not use a single indicator. We used a set of indicators for gentrification. This we actually developed from, we reported this method in another paper, and then we used this method, a set of 7 indicators, percentage of managers, administrators, and professionals, for instance, and then the income level, the household like composition, the rental household, and so on. So all those 7 indicators there. And then we actually not use just yes or no as the binary indicator, because we have the indicator and then some match the yes no and then some so we have 0 1, and then we can aggregate that. If a suburb have 0 doesn't meet any of those 7 indicators, then we say there is no gentrification. If a suburb meets some of the criteria, then we have an indicator ranging from 1 to 7 as to indicate the extent of gentrification that the area might be going through. If a suburb getting to an indicator of 7, that means it meets all the 7 criteria, then it's obviously already in the gentrification process. So that's for gentrification. And densification also is a over time process. So we measure the gentrification, densification over time as well. So that's the method. And then using latent class analysis, which a lot of social scientists do understand, and then so I won't go in detail to explain the method. So we use the latent class analysis to explore whether it's possible to identify unique neighbor complaints subgroups across Brisbane suburb based on those all 9 types of complaints. So we come up with those conditional item probability profile for the 3 classes there. So the 3 class, one is high complaints. So number of complaints are high on all categories. And then the second classes are noise complaints. So those type of suburbs have much higher complaints on noise. But then the other type of complaints are relatively low. And then the third category is no complaints, which means that all types of complaints are relatively low, small number of complaints in those suburbs. So this, you can probably consider those are good suburbs that have a very small number of complaints. And then the high means that all type of complaints are high. They complain everything, all types are there. So that's what we identify from here. So we have a type of categories. And then what we find is here for Brisbane, number one, most of the suburbs have complaints. Those with no complaints are very minimal. So only 11% have no complaints, and then all the other type suburbs have some kind of complaints, and then some suburbs have more of a certain type, like one of these three types. And then the 53% are more about noise complaints. So noise complaints become an prominent like type of complaints across all the other types. And then using a multinomial logistic regression, we explored whether gentrification and densification separately and combined are associated with the chance that a neighborhood belongs to one of these three types. So this is actually the interesting part. And then we explored individually gentrification and then densification, but we also explored the two combined, the two together, and then whether both gentrification and the densification have any impact on this aspect. And then the finding is also really interesting and then promising that I will show and then I'll come back. So method-wise, I will skip, and then I know that our students all know how to do this multinomial logistic regression. So I will come back to these findings here. So what do we find? First, neighborhood experience high densification are twice as likely to fall into the high noise complaints category. So in lay language, it basically says those densifying area, high density area that have twice as likely have a noise complaints than other type. So that's number one findings there, because higher density, people are living closer, less space, and they used to have a bigger space, and then noise become a prominent issue there. So twice as likely to complain about noise. And then the second thing is that looking at gentrification, rising gentrification also associated with noise complaints, but there is greater odds of encountering a broad range of neighbor problems than just noise. So basically what it says that in gentrifying areas that all type of complaints emerge, not only just noise complaints, they complain everything. So people complain everything, all type of problems exist across the whole area. So that is what basically these findings say. So which is also understandable. There is a mix of class there, and then there is conflict between different class and different criteria in what they consider acceptable, and they wanted to complain. However, the third part is when we look at the combined effect, both areas that are experience both gentrification and the densification. So the interactive effect between those two. So whether those areas have more complaints, less complaints, and then what is going on there. So what we find is that rising gentrification and lower relative densification is twice as likely to encounter noise problems than rising gentrification in concert with rising densification. So what does it say? Is in lay language, what we are saying here is that for areas that are experiencing gentrification but not densification, then there are more complaints. It's twice likely than those have gentrification and also densification. So in other words, areas that have both gentrification and densification have less complaints. People are living here happily. So meaning that for areas that are going through gentrification, then if densification also come in place, then people live closer, people are more tolerant to each other, and then less complaints. So that's actually an interesting finding. Residents in gentrifying and densifying neighborhood appears less likely to complain. They live and then maybe they live happier together by having those mix of classes and then living closer together. So what we can conclude from here, neighborhood annoyances in gentrifying suburb have more to do with class than with residential densification. And then we also have some other observations. The desire to create advantageous neighborhood social capital as likely to create problems as induced neighborliness. And then we also say that residents in neighborhood with high density and gentrification may be more tolerant or seek to avoid conflicts by putting up with problems. And then residents in multi-unit dwellings may resort to other governance mechanisms such as body corp to complaints. However, that part, we didn't explore this avenue. So meaning that in high density areas, densifying areas, maybe we didn't collect those data that people have complaints but reported to the council rather than reported to the body corp or to the on-site manager rather than going through the council. So that is an issue that we probably need to explore in future. And then given time, I'm going to be very quick with the next two studies. So basically, I'm just going to say that with this spatial data mining that we get the neighbor related complaints issue there, we can actually do a series of other study as well. So this one looking at the influence of neighborhood context on neighbor problems. So so what we are looking at is that we want to see whether people where people live, the context of neighborhood, whether that influence neighbor relations. And then we use a set of theoretical contract and then proposed 5 hypotheses to explore the social, interactive, environmental, and geographical mechanism of neighborhood problems and test whether this hypothesis hold or doesn't hold through a set of logistic regression models to explore those three type of construct. And then we identify whether the set of the built environment, for instance, the built environment, typically we consider using the 4D factors, density, diversity, and then destination accessibility and so on, whether those built environment factors have any impact on neighbor relations. If we look at back in the time that there are some studies looking at the neighborhood factors can impact on education, on income, and then all those factors that are maybe clustered and they impact on those factors. So along that line, we are looking at whether neighborhood characters impact on neighbor relations. And then the findings that we get is that the source of neighbor problems that are typically reside in the combination of the social interactive dynamics of the neighborhood itself, including the conversation of resident populations and the environmental features of the neighborhood, for instance, the conditions, the densities, and the use of the dwellings. So those are the sources of neighbor problems, but not the location of the neighborhood relative to the larger scale of political and economic forces of the city. So I wouldn't be able to go in detail to explain what this. I can go in detail and then talk about this, just this paper in one talk. And then the next one, we also used this to look at the seasonal variations and then to see how does the weather affect or impact on the noise complaints between neighbors. And this one also published in the paper. So whether there is seasonal variations of complaints due to weather. And then I listed some of the key findings that we identify. For instance, that we say that neighbors largely complain about noise made by animals, and such complaints most frequently appear in the March to May season, which is the autumn season in the southern hemisphere. So in autumn, more noise, beautiful seasons, and then they don't want, they are less tolerant with noise. Beautiful seasons, they want to enjoy the environment. And then there is culturally diverse suburbs with less green space tend to have a higher likelihood of noise complaints between neighbors in the spring and the summer season. So, and then we also say that a high level of wind, humidity, and temperature is associated with a higher likelihood of noise complaints between neighbors. And then there are a number of other findings there as well. For instance, the effect of weather on animal and non-animal related noise complaints vary by season. So different seasons, this type of complaints have substantially different patterns here. Weather conditions may serve as a psychological moderator to change people's. So what we are saying there is that weather conditions is not directly impact on those issues, but rather impact on people as a psychological factor, and then people may be less or more tolerant than other seasons if in the severe conditions, for instance, very hot, and then you hear some noise there, and then you probably become less tolerant. So that is more about a moderator to impact on the sensitivity to noise. So that's what we thought, and then that could also come to do some more studies in terms of the everyday noise and how it can actually impact on the work. So given time that I'm just briefly mention about these studies, there are actually some other studies that we also looked at in relation to neighbors and the neighbor problems. So what I wanted to say that the emerging large-scale administrative data are increasingly being used by researchers to explore a range of social, spatial phenomena and issues in our urban space. And then even though personally, I haven't seen any study looking at using this administrative data for neighbor-related issues, but I do see a lot of studies looking at neighborhood-related issues there. So it is becoming increasingly being noticed, and then people are using this type of data for social spatial related research. And then we have illustrated this set of administrator as a means of learning more about the social life of urban areas, how this is informed or affected by the built environment, as we mentioned about those other studies that we did. And then we also wanted to say that the analytical function of GIS does offer a lot of potential for us to deal with this type of data, that particularly for our computational social science scholars, that this can be very useful for us to have and then use this spatial analytical approach to identify, to provide evidence base for our decision making and then for our policy analysis. There are also a lot of potentials that are ongoing, even though our ARC project has been completed actually 4 or 5 years by now. There are still a lot of potential and ongoing interest that we wanted to explore. And then so we still wanted to work on this type of data and possibly in a different context, like in Asia and then in Hong Kong. And then so if there is interest, there are collaborations, we are very happy to do it. And then finally, this is an acknowledgement, which I mentioned at the beginning, that it is a project that we did at the University of Queensland before I come to CUHK, and then with my colleagues at like UQ. So that is acknowledged in this work. It's a joint research with our team. So, what is the time? I don't know whether I went too far. Maybe just about
It's just
right.
it's okay. So just 1 hour.
Okay.
So we still have
Mm.
like 20 to 30 minutes for Q&A.
Okay,
Yeah.
wonderful. So, any questions and then anything for discussion that is very welcome.
Yeah. Just just raise your hands or
Yeah,
post your question in the chat box. Any
yeah.
questions?
Or I can stop the sharing, and then so we can have a more a discussion. Or if there is any slides that I can show, I can come back.
Yeah, that's great.
Okay.
So any question?
Yes. Can you hear
Yeah, thank
me
you,
or can you?
Eric.
Hi, Eric.
Oh, hello. Well, first of all, Professor Liu, thank you so much for the presentation. It was really interesting. Um, I've I'm scribbling notes as you're going along, so I'm not sure if I can put together a coherent distillation of those. But I like the way that your research agenda has evolved, and keep building on the prior ones. I think that gives it more and more richness and makes it more and more robust as you proceed. A lot of this is quite familiar for me, just in different contexts and in different ways.
Mhm,
I mean, just a slightly personal version of this. Um, 45 years ago, when I was working for the city of Vancouver,
mhm,
there was a similar sort of one of the projects I was working on was the city of Vancouver was looking to increase residential densities in
mhm.
the core of the city.
Yeah.
And one of the concerns that they had was how would this affect the delivery of services, public services?
Mhm,
If densities become higher, what does that mean for policing services, for water quality, for fire services, for libraries, for parks, and all of those kinds of things? And so that was actually a project that I was working on and that then evolved into a research agenda that carried through my early years as a baby professor long ago. So a couple of things. I think one is using the GIS platform allows one to contextualize these
mhm,
data in a very nice way. And I think the way you do that is very persuasive. Um, the one thing that I would point to, the way we approached it back then was from the perspective of a production function.
mhm,
And this is a kind of an economics orientation, right? That what the city does is it delivers public services.
mhm.
And services might be, for example, safety, public safety,
Yeah.
or amenities, other kinds of services. And so the way economists tend to do that is they think, well, we're producing a local public good. What are the inputs, in terms of, for example, the local government budget? What are the outputs? And I think a key place where your approach can really add a lot of value to that is kind of thinking about the adding the demographic and the geographic
Mhm.
variables in the production function.
Mhm.
So when you're presenting it, in a sense, you've got an implicit production function, but not using, not making it explicit, not saying, well, here's a production function. And there are some techniques for modeling production functions that are well developed that might also add value to this geographic approach. So I think the geographic approach can add value to the kind of economic production function approach and vice versa.
Yeah,
And it
that's for sure.
seems to me that as you're progressing further and further, there's an opportunity to kind of combine those
Yes.
in a very rich way. And I like the way that you've been moving in that direction. The other thing that I find very interesting about your approach, which is different from some of the other ones that I've seen, is your focus on the complaints, right?
Yeah.
And this is interesting in a couple of ways because it seems to me that you know in the kind of production function approach uh, that I've been involved with and that I've seen, there are kind of objective measures of service quality. What is the
Mhm.
quality of the water? What is the water pressure? What is the response time for fire complaints? Or how many acres of park space are there within a given distance per population? Sort of objective type of measures in a way. Whereas complaints are a different thing, right? There's a more of a kind of a sociological aspect, which I think really is quite interesting. And in a way, it may be more relevant, right? Because for those of us who live in Brisbane or wherever we might reside, Brisbane or Vancouver or Hong Kong or Los Angeles, in a sense, it's how do we feel about it? It's not what does some, social scientist looking at data think about the service level. It's how do we residents who are living there, how do we feel about it? And one indicator of that is complaints. So I think that adds a kind of a sociological dimension that you lay out quite nicely. And you also point out some of the, sort of advantages and disadvantages, I think. So, for example, I like your pointing out the fact that, the complaint variable is itself subject to some kind of bias, right? Sample selectivity bias, as you point out. Maybe other people are complaining, but they're complaining to the building manager rather than to the 311 line or whatever, or the cars,
Yeah.
line. And so those are the kinds of methodological issues. Also, I think you're kind of hinting at, or even, expressing directly, there are kind of endogeneity concerns. And again, this is where a production function formulation can be helpful, just because in this kind of modeling of production function, endogeneity, for example, maybe certain kinds of people live in certain kinds of neighborhoods, right? And so is it a neighborhood effect or is it a person effect, right? And unraveling those is tricky, and it doesn't matter, what approach, right? It's intrinsically um, quite difficult. And two last comments here, and sorry to go on so long. Um,
Thank you.
One is, I also like the fact that you're looking at actually change data, that you're looking at gentrification and densification as actually explanatory variables in the production function, what I would view as being the production function, because that also gets to a different psychology. And I think it uh, might help explain that very interesting result that you pointed to about the fact that when there is no densification change, but there is gentrification change, you get more complaints. And I think what that shows you is it's this we're being sort of invaded by a different mindset, right? Of what's acceptable and not what is acceptable and what is not. And that's very difficult to capture other than through these kind of complaint variables. So that's a very interesting result that you point to, and I think can be even mined further. The last comment I'll make, and again, my apologies for going on so long. I liked your last little bit about the weather and
Mhm.
how that affects. And in English we have this expression "fair weather friends," right?
Yeah.
A fair weather friend is someone who they're your friend when everything's going well, but when you're in trouble, somehow they're not your friends any longer, right? So those are
Mhm.
fair weather friends. So in a sense, you've got fair weather neighbors that you're uncovering with your data. So
Yeah.
it's fun. So again, thank you.
Thank you very much for your comment here, Eric. So that is really good to hear. I totally agree with you. Like the difference, particularly in the traditional production approach and then or the planning approach as well. Looking at more about how they consider about more about how we plan the cities, how we should lay out the road and then the facilities there, rather than considering how people will perceive and live there and how their life might be like. So I think this type of research actually does give us a more person-related approach. So I think there is a shift in certain areas, or particularly I know that some planners, they are thinking about planning the cities for people rather than planning for cities. And then it should be more how we should develop and plan our cities for where people live and how people would like to live there. And then so I think that this is an important kind of mindset shift, particularly in the design and planning and then the production of our cities and the environment. And I do enjoy this line of research deeply through this project. And then so I feel there is still a lot of things that we can dig further. And you pointed out a few things there. I think that is important. For instance, like the people, we wanted to look at the completeness aspect. Like for a while, it's difficult, but it still can be done. And then it's just at the moment I changed the positions and then our project finished, so there is no more further fundings to do it. But still, it's important to actually look at these issues. I think particularly that using this type of data, not only just for Brisbane, it actually can be, I hope more people can actually take note of this kind of research to look at this related neighbor problems that can be used to guide us to understand how we can manage the cities or how to manage the cities for the better aspect.
Mm.
So thank you very much for your comments.
Okay, thank you. Thank you very much. Any other questions?
Yeah. Let's
Oh,
see if there's
there's a
any
one
questions
chat box.
in the
Yeah.
chat box. Okay, this is very
Future
interesting.
research plan in multidimensional neighborhood analysis.
Okay, I saw one here. I'm really hearing more about, oh yeah, research plan in multidimensional neighborhood analysis. Right. I So with my the current this type of work in Brisbane, we haven't got actually any concrete plan to continue the work in Brisbane, given that I've now relocated to Hong Kong. Uh, However, we are still very interested in continuing this line of query. For instance, whether it's possible to get data for Hong Kong, also for other cities in the Asia context, and then we can possibly see, hopefully, a cultural background and then difference, whether there is anything different from what we observed, particularly in terms of how the changing urban process relate to people relations. So that could be something that we would be quite interested to explore further. But I understand that there are also data access issue there. So how we can convince people that this data can be used for academic purpose. We did that when we were in Brisbane. Michael, particularly like Linda lead that process. It took almost 2 years to convince the council that the data will be in good hand and we are not going to breach any of the confidentiality issues there. So we have to go through this process. And then the other side, if we, like Linda, myself, both are very interested in looking at those unneighborliness issue. We are thinking, even though we don't have any funding to do that, but we are thinking that maybe we could get PhD students to come on board, and then we can do particularly this unneighborliness type of research, even using the data that we have got in hand.
That's really fascinating. I was unfortunately just a little bit late to the presentation because I had an overlapping meeting. My apologies. So if I've missed anything, I'm sorry for that. But it was so fascinating to see the different dimensions fused together to find out more about the nature of society and the fabric of society. And I love the idea of you putting cultural issues into the mix to find out, is it different in different cultures? Only reason I jumped in and said something now is because it occurred to me that sort of in our area, I'm the UNSW in Canberra, and in our area, a few of us are starting to get very interested in the notion of smart cities. And when you were talking about funding, I thought, maybe that there might be some funding that you could find in associated with smart cities, because that's a really big topical area now, and that might be an interesting alignment for your research, which was really, really nice. Thank you so much.
Okay. Oh, thank you for the suggestions. Yeah, I will certainly look into that.
Okay, thank you both.
Um,
Yeah, yes.
I don't know if I can chip in, and
Sure.
thank you, Professor Liu, for a wonderful talk. I have one comment and question for what you just presented. I think it's a very interesting work, and I think there are many things we can draw inspirations from. And I can see this project can go into 3 possible directions in the future. One, I was thinking, is we can also model the spillover of the causes for those complaints. So we can do the spatial econometrics to see whether those social economic factors can have spillover effects on having those complaints. And the second, I was thinking, if one collects historical data, we can also see the rise of gentrification and also other densification factors that can also explain the occurrence of complaints, right? And the third I was thinking is we can also maybe measure the outcome differently. We can aggregate those complaints and to see if there are aggregate level patterns, and we can explain those variation. And one particular question I have is about I've seen that you have the boundary data for those properties. And I was wondering, in a lot of cases, researchers only have point of interest data, which is just the location. And I was just thinking, in the field of geography, what would be the state-of-the-art approach to really measure the boundary if we don't have that ready to use data in particular? Yeah, thank you.
Right. Okay. Thank you very much for your suggestions. Those 3 directions are really interesting, and then I will certainly be happy to explore further. And then if you are happy, and then we can actually explore together. And in terms of the data issue, right? And then Sorry, I just got a blank there. It
Sorry,
reminded me.
the property boundary.
The
Yeah,
property boundary,
yeah,
yes.
yeah.
Depends on which geographical area region that you are from. Are you local in Hong Kong or somewhere
Um,
else?
I'm actually a CHK postdoc. I'm in political science, so it's
Okay, yeah. Right. If let's say if in Australia, all the property boundaries are actually publicly available.
I see.
So it's one of the government initiative that make common data available. So used to be quite expensive. You have to purchase, but now it's all available. But then we will just need to use some of the GIS skills to extract the type of data for your areas. At least I know in Queensland the whole data set is free, and then in some other states I know they are also freely available. In other contexts, like in Hong Kong, I know government also put a lot of data publicly available, but I haven't dig into detail on whether there is similar type of property boundary data. But Hong Kong is a different context, a lot of high rise, not like the detached house and properties as in Australia. So we will have to consider those boundary issues in different ways. Yeah.
Yeah, it's a challenge. So, as far as I know, people like me who study villages in China,
Mhm.
you can download shape files with the boundary polygons, but it's not publicly available data source. It just like work throughs. So
True.
one would probably be able to download those point data from either Google or Baidu, and this will involve the estimation of those polygons in a
Mm-mm.
systematic way. So I think it's still empirical challenge for people to solve those issues if they don't
Mhm.
have to ready to use database.
Mhm.
And I think this is what probably the field needs to address in
Yeah,
the future.
yeah, yeah,
Yeah.
yeah.
Thank
Other than point data, you can probably also consider those OpenStreetMap that
you.
may have some polygon-related data, but I know that the data is probably somewhere available. It's just how to get access to the data is an issue. Yeah,
Thank you.
yeah. Thank you.
Oh, okay. Probably the last question from the audience. Any? Come on. If not, I'm going to ask the last question.
Thank you.
So, my question actually is related to the measurement. So, uh, I'm very interested in this topic about the neighboring issues. So, as I agree with Eric, okay, just mention about that you're using uh the complaints as a very important indicator, and I do agree with that. This is a very important indicator, and also it's a very objective measure. So my question is that about the data. Okay, so I'm not
Mhm.
sure that you have the content of the complaints. So if that possible, that you can still to measure something even more interesting, at least for me, so that to like to measure the interpersonal relationship among the neighborhood. So because that is a complaint as now currently characterized as about some animal issues, noisy and whatever. So I guess that sometimes, okay, in addition to those categories, those kind of, I agree that those are also very important issues, but I think sometimes when we're talking about neighborhood, I just know whether our neighbors are friendly or not, whatever. So is that possible?
And the data sets does have a description about the issue they reported. So that is the console when they receive, and then they have either if you submit online, you will have to explain the situation, and then
Hmm.
or if you call, and then the receiver will have a description. So we do have that descriptions on the database or on the data that we get. And then we thought we could also use some large language model to do a text mining to understand those data. That is still possible. We haven't got hands-on looking into that. I do know machine learning, and then I do know this the methodologically, but unless we get someone on board that could be have the interest like a student, then we could have a project working on that. If you have students, and then we can
Yeah,
work together.
we have a lot of students in here, okay, in the room.
Yeah. So if there is any students, any have any interest there, and then we certainly could have a lot of like more work to dig into the data. Is a very rich set of data. So I didn't mention actually once we get the channel open with the council, actually they initially gave us 11 years data. In the middle of the project, we analyzed the data and then gave them a report back, and then we gave them a talk. They were very pleased to see how the data can be used and how they can use that to understand the city and then to help improve their management. So they gave us another 3 years of data and then say, can you continue and analyze this data for us? And then after that, actually going through COVID, we were also interested in say whether we could see any difference, whether people are living more happily together given the lockdown, or there are some other things that are happening. So certainly methodology still is a set of methods that can be used straightforward. And then if we have time and people power, then we can continue this line of work. As Eric mentioned, it's really a nice work that can be continued and then could be continued. Yeah, maybe we should apply for another funding for that.
Yeah. So, sorry about that. I just missed the one question
Yeah.
from your student from GRM,
Yeah.
year one PhD student. 新金 or 金星 same.
Okay. So Sean is here. Okay, let's say study two reveals how gentrification can produce different spectrum. Wonder if we could use agent-based modeling to simulate the underlying social dynamic, for instance, modeling affluent of high income. Yeah, certainly. That can be done. In principle, methodologically, I'm sure we have to play around with the agent-based model. I did use agent-based model for urban development, like simulation to look at, for instance, the developers' behavior and how it impacts on city change. And then so we can also use agent-based model to simulate the behavior of those people and then see collectively how it could come with some outcomes from there. So if you're interested there, we can talk further.
Yeah. Okay. Thank you. Unfortunately, we cannot take any more questions. So I know you must have a lot of other. You must have a lot of ideas as we just discussed. This is a rich data, and there are a lot of potentials that are already seen. So, if you want to, if you have any ideas that for our own students, so it's our privilege that you can talk to Professor Liu directly.
Yeah.
Yeah.
Okay. Thank you very much.
So thank you, Professor Liu, and also thank you all for coming today.
Thank you,
Yeah.
everyone, and thanks all for your listening and also the very positive feedback and then comments there. Thanks a lot. Okay,
Yeah.
pleasure to be here.
Yeah, thank you. See you. See you next month.
See you next month. Yeah.
Yeah. Bye bye.